Welcome to today's lesson on stretches and shrinks for transformations. By the end of the lesson, the goal is to be able to describe whether a graph has been stretched or shrunk and in what direction, horizontally or vertically, and be able to create an equation based on a written description. So the first thing we want to do is just kind of investigate what's happening. Okay, starting with our parent function x squared, or quadratic. Okay, we look at the fact that we're adding a 2 to the outside of this function. Okay, in some ways it might be hard to notice it's outside, but if parentheses are not there, you want to put parentheses around only the x value to help you identify the inside versus outside situation. Okay, so we have an outside multiplier by 2, and one thing we want to look at is critical points. When we're graphing the quadratic, our first point that we see on either direction of the central point or vertex should be a negative 1, 1 or a positive 1, 1. Excuse me. Now, when we look at the red graph in this situation, we can see that when we go over 1 in either direction, now we're going up 2 units to get to that point. Okay, so we can see the vertical distance now is a vertical distance of 2 to that first value when we're going horizontally 1, compared to the original graph where the vertical distance is 1 for every horizontal adjustment of 1. Okay, so in this situation, what happens when we multiply on the outside? We'll go through our head shake rule. Outsides we trust because it's a vertical outside transformation. So this is a vertical stretch by a factor of 2. Okay, so if we think of vertical stretches, we remember that verticals are always affecting our y values. So our y values are getting multiplied by 2. Okay, the head shake rule on that high bow tells us we trust what we see. We have a multiplier of 2 on the outside, so we multiply all of our y values by 2. Okay, now, once again, we know this one will be vertical. We put parentheses around only the x if the parentheses aren't there. The 1/2 is on the outside now. Okay, once again, looking at our original graph, we've got a 1-to-1 ratio from the vertex point in the center to our first perfect point. Now, when we look at this red graph, we are still going horizontally 1 unit, but now when we look at how far we're moving overall, we're only going up vertically by 1/2. Okay, using that high-vol rule, we're on the outside, we trust what we see. Okay, so that multiplier of 1/2 is vertically shrinking the graph. So we have a vertical shrink by 1/2. Okay, the important part is really talking about that stretch or shrink, because the number that we multiply by, we're using that as a scale factor. It's always a multiplication. So whenever we shrink, it should be a fraction. Whenever we stretch, it should be a whole number value. Now, let's look at the horizontals. Okay, the parentheses are back in place. We can see that we have the multiplier on the inside of the parentheses. Once again, we're looking at that original graph that has the 1-to-1 relationship. Okay, from that 1-to-1 relationship, now we look at the red graph, and we're always looking for a 1 unit change in one direction. So now we've got a vertical distance of 1. And then we can look at and say, how far has it changed horizontally? We've got a 2 unit distance in the horizontal adjustment. Okay, if we go back to that high-vol rule, horizontals are on the inside of the parent function. Head shake rule tells us we don't trust what we see. So we see that 1/2 on the inside. We're not going to trust that value. It is horizontal. Okay, but instead of 1/2 shrinking it horizontal, it's actually a horizontal stretch. And what we have to think about is the reciprocal of that value. Okay, so we're not trusting the 1/2. We have to either divide by 1/2, but that's the same as multiplying by 2. So we're using a reciprocal operation when it's on the inside. Horizontals are affecting our x values. So in this case, we're going to do our x's times 2. It's the hardest one to remember that when you're inside, you want to do the opposite operation. So you could divide by 1/2 or multiply by 2. Okay, last operation we'll look at, we've got the inside multiplier of a positive 2. Okay, we start with that 1-to-1 relationship again from the original graph. That's what we're always looking for, and that point, it holds true in any other situation. But now, in this case, when we go up 1 unit vertically, we can see that horizontally, we've only gone a 1/2 unit in either direction. Okay, so we're looking at that relationship between the two. Okay, once again, if you kind of follow that high-vol rule, inside values we don't trust. So this situation, it is affecting the horizontal because it's inside the parent function, but it's going to be a horizontal shrink because we're going to do the opposite of multiplying by 2. We're either going to divide by 2 or multiply by 1/2. Okay, we like to talk about it in multiplier terms over division terms. Okay, but mathematically you can do either operation. So our x values are going to be multiplied by 1/2 to make that shrink. Okay, we always have to remember that inverse operation or the reciprocal value when dealing with horizontals. Here's our general rules. When we look at the vertical stretch or shrink, we're looking at a multiplier on the outside. Okay, it stretches when a is over 1. It shrinks when it is a fractional value. Okay, we do have to stop at 0 because if we go to negative, it would be a reflection with some type of stretch or shrink. Okay, so we're really looking at that absolute value of a when we're making these comparisons. Okay, the horizontal are always the more difficult transformation. Okay, we've got our multiplier on the inside, and you just have to remember that head shake rule. Don't trust what you see. Do an opposite operation for that multiplier. So it's actually a stretch by the reciprocal of b if b is actually a negative or fractional value. Okay, and it's a shrink if your b value is greater than 1 because you do have to apply the reciprocal before you apply it to your function. So now, describing transformations. Okay, we brought in some of our other parent functions in this case. So it's always about placement. This -5 compared to the parent function absolute value of x is outside. Outsides are vertical. Vertical head shake tells us we trust what we see. So this is a vertical shrink by 0.5 or 1/2. Looking at the next operation, our y equal equation here, upper right. We've got a 2 multiplier on the outside, but we also have a negative. We've got a plus 5 on the inside, plus 7 on the outside. Okay, so we're applying this operation, we're looking at every value, and we have to describe each piece. So now if we go back to some of our previous lessons, a plus 5 on the inside, we don't trust. Horizontal, inside, horizontal head shake tells us to not trust it. This is going to be a left 5 movement. Plus 7 on the outside. Outsides are vertical. Vertical head shake tells us to trust that value. And we're going to go up 7. The 2 on the outside is a multiplier. Okay, outside vertical. Head shake tells us to trust. So we have a vertical stretch by 2. And then the last piece we have is the negative. Okay, and that negative on the outside would be a vertical reflection. Okay, so that's actually the most operations we can do to any one graph in higher algebra. We can flip it vertically, stretch it vertically, up, down, and left, right movement. Okay, looking at a couple of these last ones. Parent function, inside, dividing by 4. Remember, insides are horizontal, and we don't trust those values. Okay, so this isn't going to shrink the number like we think it would. This is going to be a horizontal stretch by 4. Okay, instead of dividing by 4, we have to flip that value and multiply by 4 to make that work. Okay, let's skip over a couple more of these examples and jump down to this bottom one so we can see just some different operations. A multiply by 3 on the inside. Insides are horizontal. Horizontals, we don't trust what we see. So we know it's a horizontal adjustment. That's not the difficult part. The high-vol rule helps us with that. But what we do have to remember is we're not going to trust that 3 as a stretch value as a multiplier. So this is going to be a shrink of my graph. And our shrink factor is 1/3. You always want to think about the reciprocal, try to find that multiplier value. Now, last part for this lesson is creating and building an equation. Okay, when we think about the equation, our parent function is absolute value of x. We've got 4 positions that we can put things in for our operations. And then we have to just look through and classify each piece. So the first thing we have, horizontal shrink by a factor of 4. Okay, so we have to remember, if it's shrinking it, okay, shrinking would normally be divide or a fraction. Okay, we know multipliers are going to go inside, in front. So the opposite of dividing, or the opposite of fraction, is a whole number value, or multiplying. Okay, so that's our horizontal shrink by a factor of 4. The next piece we have, reflection over the x-axis. Okay, you want to be careful and think about the axis there. If we're going over the x, that is a vertical reflection. Okay, if it's vertical, it's an outside value. The outside negative multiplier is what flips the graph. And then the last piece that we have here, translated up 5. Okay, up, down is vertical. Verticals are on the outside. Okay, so we know that that's going to go in this position. And we're going to have a plus 5 in that spot. Last example here, the graph of x squared parent. So you want to think about the 4 positions that you can input information into. Okay, so we expand the parentheses to give us the 2 spots on the inside, and then we place the 2 spots on the outside. First thing we have, vertical stretch by a factor of 5. We know verticals are on the outside, so stretches are multipliers. We'll put the multiplier in front. So we trust the vertical stretch, so we input the number as we see it. Okay, verticals are always easier than the horizontal transformation because you do what you see, you work specifically with that factor. Okay, now we have a horizontal stretch by a factor of 3. Horizontal multipliers go on the inside. It's a stretch, which should be a whole number value, but we understand that when it's horizontal, we don't trust what we see, so we have to input the reciprocal of that. And then finishing up, we've got a left 6 and a down 2. Left 6 is inside, so we're going to place that in our inside position. We don't trust what we see for the left, so we have to call it a +5. And then we have a down 2. That's going to go on the outside, okay, with a -2 in that value. Okay, and that concludes today's lesson on communicating about horizontal and vertical translations or stretches and shrinks.